Okay, let's start. My name is Sanjeev Kumar, and I'm working as a senior engineer in Gurgaon region. So today we are gonna discuss about the interpolation and synchronization functions using RD78G simple motion module with the MRJ5 servo amplifier. So first of all, we are going to cover this content. We will see MRJ5 servo and RD78G simple motion module basics. Then we are going to perform different servo operations using the function block library, which is made available by Mitsubishi Electric over web. Anybody can see, can download the library and import into the GXWorks 3 software. So we will see what are the function blocks which are available to use interpolation, what are the different steps. We will see for synchronization how we can achieve synchronization and different camming function. So if we talk about MRJ5 servo amplifier, this is very new amplifier and it's a successor for MRJ4 servo amplifier. MRJ4 was like 22-bit amplifier, but in J5 we are using 26-bit encoder, and also it is supporting connectivity features like CC-Link IE TSN. It is having progressiveness, like it has performance improvement, program standardization we can have in this. Usability, like different tools are available for quick diagnosis, quick operation start. Maintainability is higher in this, like we can have predictive and preventive maintenance features, corrective maintenance features inbuilt, and heritage, like we can use our existing product line products with MRJ4 and MRJ5 amplifiers. So if you talk about CC-Link ITSN and MRJ5, so MRJ5 series is a high performance and industry leading servo amplifiers which features a unique control engine that is more powerful than ever before. Like it is more powerful, it is more fast than J3, J4, and this is also this can also connect to CC-Link ITSN to perform high performance, high precision, and high speed control, position controlling. So it is also available in multi-axis servo amplifiers, like you can have MRJ5 W2, W3 amplifiers, which are 2-axis or 3-axis amplifier. So if you talk about like what is the simple motion module which can be used with the MRJ5 amplifier. So this is RD78G. Okay. So RD78G can be used with multiple core processors. It is having multiple core processors and which enables to configure a high speed large system by supporting the CC-Link ITSN real time open network. Okay. So RD78G also supports CC-Link ITSN, and our servo amplifiers like our MRJ5 70G, 20G, 10G, these all are supporting CC-Link ITSN. So it also performs positioning control such as linear interpolation using function blocks. Okay, that's what we are going to see today. Okay, we are going to check uh, function blocks. Okay, with function blocks we are gonna do interpolation and synchronization. The programming which is easy, and users just need to set positioning data to the function blocks. Okay, so it also connects to various modules such as servo amplifiers and IO modules. So in CC-Link ITSN, we also have servo amplifiers and IO modules also. So like in CC-Link I field, we have AJ65 SBTB1 or NZ2GF2BF11. These remote IOs are available. The same IETSN also having the remote IOs, and it and the servo amplifiers and remote IOs can be connected easily over a single IO network. Single network connect allows you to configure a servo system more flexibly. So it supports a consistent engineering environment that is capable of handling tasks ranging from like system design to debugging and maintenance. So CC-Link ITSN is going to be much more user friendly, much more easy to use and easy to design. Okay, so if you talk about RD78G simple motion features, okay, this is all. This can also work as simple motion module. Like earlier, we have RD77 MS, MS4, MS8, MS16 simple motion modules. So this can also work as simple motion module over CC-Link IETSN. Okay, so this can positioning control can be easily performed with motion profile tables. Synchronous control can be executed only with parameter settings. Remote devices are connected via CC-Link IETSN and programmed from PLC and CPUs. Okay, remote devices can be connected. Like RD77 MS, we have also done the interpolation and synchronization, and the data is synchronized with the motion operation cycle can be collected with the digital oscilloscope. Yes, there is also digital oscilloscope available in the settings. You can easily monitor the different motion operation data. The collected data can also be displayed in waveforms for operation verification. Okay, so for this, what we need to do, we have to first import the RD78G library for positioning. Okay, there is a library available on the website. You can just download that library to your system, and you can just import that library to GXWorks 3 and use the different function blocks available. Okay, I will show you the link of this library to download. You can just download and use the function blocks available. So just download from here, and you need to import your downloaded library as shown here. Like you need to right click anywhere and register to library list. In the element selection, you need to click on register to library list and library. So you will be able to import your library in your GXWorks 3 project. Now, different kind of function blocks are available in this library. You can see here. So motion control RD78 library is available here. In this, you will have different function blocks like for error reset, like for uh, power, all power, and which is all axis servo on. You can have different positioning operations like absolute positioning, relative positioning, velocity operations, homing operations you can have. So all this thing you can have from the library using function blocks. So we are going to see these steps practically over GSOS 3. And right now I cannot show you the hardware. So I will perform these operations using simulation. So you can have more details about MRJ5 servo amplifiers and the library. If you go to the Mitsubishi Electric website here, FA website, here you will get the link of all the factory automation products, and I will drop this link to the chat box so that you can also explore. So what I'm going to do here, you can check our different products. So if I go to the MRJ5 products, drive products, and AC servo, Mel servo J5. So here you can get more information, the more details and more properties, functions, specifications you can get here. So here I have a small product video. You can have a look from here. If you click over here, so this was a product video of MRJ5. So if we want to download the library for RD78G, you just need to click on download, and you have to come sample library. Okay, click on sample library, and here you will get, you can go into Japan website, and here you will get sample libraries. Okay, in sample libraries we are having control equipment and IQR series. So here you can click, and here we have sample programs and libraries. So here you need to click on motion or positioning units. So if we click here, uh, here we are having simple motion unit and PLC Melsec IQR motion unit FB library. So you can click, uh, if you see here. So you can have the library. These are the target form name: RD78, G4, G8, G16, G32. So different product library is available here. You can download the latest version, motion control, RD78G underscore 10K, or whatever you want. In this, you can see there are different function blocks available in this library. All these function blocks are available. Okay, so we will see how these function block can be used in our webinar today. Other than that, you can also click on simple motion unit. Here you can also get the library. RD77 MS library, GF library is here. So we need to go to RD78G4 like this. Okay, this link I can share. I'm dropping this link to down so that you can also download and try by yourself. I have dropped into the chat box. You can check these links. So I have downloaded this library. Now what you have to do, you need to click, you need to open your GXWorks 3 software. Here, if you configure your module configuration, so I have taken, here I have taken this CPU R61 supply, and the CPU is R02 CPU, and also I have taken RD78G4. Okay, with this you have to connect your servo amplifiers. Okay, if you click on this, so its properties will be available, and if you open the property, from here you can check like RD78G4. When you right click and you need to click on fix, then your properties will be available here, RD78G4. So here different parameters are available for RD78G4. So you need to first configure your network in module parameter, network setting. You need to click on detail setting. Okay, in detail setting you have to take your servo amplifiers. Okay, so I have connected two servo amplifiers, MRJ5 and MRJ5G. For that, you just need to take the servo amplifier from here, general purpose AC servo. Just click here and just you need to take and drag and drop. So I have already created a project to demonstrate you, because it will take more time if I create a project here. So these two amplifiers are available. After creating the project configuration, you just need to click on close with the reflecting setting. Also, if you want to open the parameters of the servo amplifier, you need to click here. Okay, if you click on detail setting, the servo amplifier parameter will be visible. If you click on yes, you can see here in this kind the servo amplifier parameters will be available. These are actually servo parameters. Okay, all the parameters are available here into the list form and in function list display. So we don't need to change the parameters, these parameters right now. So first what I'm doing, so after setting these parameters, you need to click here, module extended parameters. Okay, module extended parameters. So a newer window will be available. This window will be available like this. So here, first of all, in the basic settings and in system setting, first of all, system setting and access settings. So in the access setting, we need to configure our access. So I have configured two axes actually. Uh, Axis 1, you need to just right click and add a new data. So your new axis will be added like this. Okay, so axis 1 I have configured into the real drive axis. Okay, you can also configure in real axis. Axis 2 I have taken a virtual axis. Okay, in virtual drive axis I have taken axis 2. So in real drive axis, axis number you need to mention axis number 1, axis number 2, like this you can mention. So I have taken two axes. One is real drive axis and other one is virtual drive axis. Okay. All the parameters related to these axes are available here. You can modify the different parameters if you require. Okay. Then if you want to do interpolate, if you want to interpolate these two axes, then you have to create a group for these two axes. Okay. So to create a group, you just need to click on axis group, right click and add a new data, and you need to mention the group name and group number. Okay. Similarly, I have mentioned the group name 1 and group number 1. Okay. In this, you need to enter the axis numbers. Okay. You just need to click on axis configuration axis 1, configuration axis 2, 3. For example, right now I want to interpolate two axes. So I have to take two axes, configuration axis 1, configuration axis 2. This name should be same as the name of the axis. You just need to copy this name and paste here. Similarly, axis 2, copy this name and paste in the group settings. Okay, like this your group will be completed. Okay, so these are group settings and these are axis settings only. Rest of the settings we will see later, or we just need to minimize this. And now what we are going to do, we have to create a small logic in the program body. You can check, I have created a logic using function blocks. Okay, these function blocks are available in the library that we have just imported. How you can import the library? Just you need to open the element selection window like this. Here in the library list, you can click right click and register to library list and library. If you click on library, it will ask for the downloaded part. Okay, it will ask for the download library like this. I have downloaded motion control RD78 underscore 1.7h, this library. Just you need to click on this and click on open. So your library will be imported. Like if I click on open, so like this, the library will be imported. Okay, in this library you are having different function blocks, management, operational, standard function blocks. So I'm going to use these function blocks only. So first of all, I have using SM400, I have made PLC ready. PLC ready signal is there. So PLC, because my RD78G is connected to 000 address. So a Y0 will be my PLC ready signal. Okay. So here, what I have to do, I have taken only one line for PLC ready. Then how to make all the axis servo on. Okay, to make all the axis on, I have taken a function block MC all power 1. You can see here. It will be available here. Management MC all power on. If you drag and drop it here, so it will be downloaded here like this. So MC axis all power on. Okay. Here, first of all, it is axis information. Okay, access information. Here you need to mention only the name of your function block MC underscore all power underscore 1 dot. Okay, like this you need to mention your block's name MC all power all power dot access information this. So you need to take this only. So it will be available here. Now to enable this block, we need to to enable this block, we need to connect the supply to the enable signal, and to on the servo we need to give a signal to this servo on. Okay, here in the right side you have access information, executing, error code signals. Okay, these are actually output signals when the block is executing. So this signal will be available if the block is executed with an error. So this block will be available with this signal will be available. Okay, so if I want to check whether my servo is available or not, so I have to start the simulation. Okay, I have already started a simulation, so let me close this simulation, then I will show you how you can start your simulation. So this is the project that we have just created. For example, we have just created all access servo on. So what we are going to do, so this is my all access servo on logic. So click on debug, simulation, system simulation, and start system simulation. Okay, you have to follow this step to utilize your simulation. Okay, if you click on start simulation, so this type of system will be visible, and you need to click on add system. So click on add system, and you need to choose your path where you have saved your path. So okay, this is the path where I have saved my project. This project you have saved at some path, so you need to take this the same path into the simulation. Okay, and just click OK. Now just select RD78G4 and click start. So your simulation is started now. Now here we need to connect with the simulation first. Click debug, simulation, system simulation, and connect simulation. Okay, click on connect simulation and click on connect. So your simulation is connected, but it is showing an error. So you need to reset the simulation. Just click on reset and click on run again. After connecting the simulation, first you need to write to your simulation first. Write to the PLC. Okay, click program parameters and write it to the simulation. Then it will not show an error. Okay, the project is downloaded. Now to check whether our servo is in servo on condition or not. So I have entered SM400, SM400 always on bits here. And also you need to take a number K1, K2, any number you can take in this bit. MC power all power underscore one, the name of your function block, dot axis number. Okay, you need to move K1. Okay, like this, move K1 to MC power dot axis number. Into this you need to move your K1 value. Which axis you want to servo on? Actually, only by moving K1, all the axis will be servo on. So I have moved the axis. Now you can reset your simulation. Okay, so you can see the error is removed now. Now I'm going to open the axis monitor. Okay, so to start the axis monitor, you need to click here in online motion monitor and axis monitor. Okay, in axis monitor you can see the status of your all the axis, the error status, the servo lock status. So here you can see both the axes are in standstill condition. Standstill. Okay, that means our servo is on. If I show you it, okay, like this. Mhm. Okay, so here you can check the servo is standstill. Now, if you want to like check, if I enter a bit here, like M100, I'm entering here, updating the program. M100. Okay. Okay, M100 is actually already used, so I have to change it. Like that, you can see now the status is disabled. Okay, I have. entered M200 here. So the status of servo is disabled right now. If you press this M200, so it will change to standstill, like this, standstill. That means servo is now in lock condition. Okay. After lock, if you want to jog, if you want to servo jog, so you can use jog operation like this. So MC jog, there is a function block available. MC jog function block available in the operation of that function block library. So you need to take from MC jog, and here also you need to take same mcv underscore jog underscore one dot access. Okay, dot access. And then in the positive rotation jog command, or jog forward jog backward, you can take any bit m3 m4 like this. Jog velocity you can take m, in terms of it will take a float value. So with e you have to take, I have moved the value from here, you can see here. So using M 400, I have taken velocity as E1000. I have moved E1000 to this 1000. Similarly, axis number, which axis number you want to rotate into jog condition. So you have to move that axis number to the MCV jog underscore one, the function block name, then dot axis number, like this. Similarly, here also you need to move ED move, or uh, move block for floating point numbers. So you have to move the velocity E100, yeah, is whatever you want to move into MCV jog underscore one. This will be the name of the function block. Okay, MCV jog underscore one dot velocity. You have to take dot velocity, the name of the input, like this, dot velocity. So your speed and axis number is fed to the function block. Okay, now if I press and these acceleration deceleration you can take any, like one I have taken. Now if I press M3, so you will see the axis will start rotating. If I press M3, you can see here my axis 1 and axis 2 both are rotating, because I have taken axis M3 for axis 1 and axis 2 both. You can see here, like for axis 1 I have taken M3, and similarly for axis 2 also, into the jog operation here, axis 2 jog I have taken M3, same M3 I have taken. So this button can be used for jog operation. Okay, jog operation of both the axis. Now after jog, we can use same, like error reset function block is also available here. Error reset, MC reset, that I have just show you in the management option, it is available. Like if you want to check, you can check in the element selection, like in reset, it is the function block for axis reset, MC reset. Okay, for axis 1 and axis 2 I have used axis 1. So MC reset, here you can take the function block name MC reset 1 dot axis. Okay, and here you can take the execution command when you want to reset the error. So in the output side you can take, it is optional. If you want to take the status of the block execution with error, or error code, you can take, otherwise you can just connect directly. Okay, so if you have any error in your axis 1 axis 2, you can just press this M5. For which axis you want to reset the error, you need to move that value. Okay, like this, like this. In this I have moved now. I have moved K1 to the block name MC reset underscore one dot axis number. Okay, so here you need to move the axis number for which you want to reset the error. Similarly, for home operation, like access 1 home or access 2 home, you can use this function block, mc underscore home underscore 1. So it is also available in the library. Here you can check it, mc underscore home. In the operation, you can check mc underscore home, OPR. Okay. You can just drag and drop this function block and your access will get home. Okay. So I have chosen the dataset method. So if I click this M6, so my both axes will get home because I have taken M6 as the execution command for both the axes. Like for this axis 1, I have moved K1 to MC home underscore 1. This is the function block name for homing .axis number. Okay. So K1 I have moved to this block. Similarly for axis 2, I have moved to K2 to MC home underscore 2 dot axis number. This is the name of this function block for axis 2. This. So M6 and M6 both are same buttons. So if I click on this M6, you can see my both the values will become 0 in both the axis status. You can check 0 0. Okay. So like this, we can use homing using function blocks. No need to design any logic. You just need to drag and drop the function blocks available in the library. Okay, after function block, if we want to do interpolation, okay, if you want to do interpolation, so for interpolation, we need three function block actually. First function block is axis group enabled. Okay, there's a axis group enabled function block. So this is just a function block. You need to take this and you need to just execute this. Okay, you can take it from here. Axis group enabled. You can find it group enable. Okay, axis group enable and axis group disable. Group enable disable. Okay, these are the two function blocks which you need to do, because initially we have created a group, right? We have created a axis group like this, axis group 1. In this there was two axes we have taken, axis 1 and 2. So to use this group in interpolation, we need to first enable this group. So from where we can enable, we just need to take the axis group enable function block. Just a minute. So to enable the group, first we need to take this function block, axis group enable. And if I press this M11, the axis group will be enabled. Okay. If you want to disable the group, you need to click on axis group disable. M12 I have taken here. Which group number you want to enable or disable, you need to take here. You need to move MC underscore group enable underscore one dot access group dot group number. Okay, access group dot group number. Okay, so like this you need to take. Okay, now I'm just enabling the group. Okay, right now I'm at the home position. You can see actual position is 0, and here also the actual position is 0. So I have just enabled the group using M11. Okay, now for interpolation, what we have to do, we have to take this absolute linear interpolation. Okay, absolute linear interpolation function block, MCV, move linear interpolation or circular, whatever you want to take, you can take here. Okay, now here what we need to feed, first of all, the access group information. You can just directly connect it, then execute command and update, continuous update. You can connect any memory bit here. So to start the interpolation, you need to take M13 bit here, or any bit with the help of which you want to execute the interpolation. Okay, apart from that, we need to give some values, like we need to give target position where our axis want to go. This is the target position for axis 1, axis 2, whatever you want. I will show you how to give the target positions. Similarly, this is the velocity for, you can say, the master axis. Okay, here what we need to take, see, here we have the data. First of all, we have to mention which is our axis 1 and axis 2. Okay, so K1 will be our axis 1. We have to feed it into the function block name linear interpolation absolute 1 dot linear axis element number 0. This is actually an array. There is an element in this function block, and which is an array element. You can see here, axis group position acceleration, like same. Just double click this and you can take here linear axis 0. Okay, linear axis 0 is actually a element number 0. So we need to move K1 into that element. That means we have set axis number 1 into the element 0. Okay, now axis number 1 we have fed to the element number 0. Similarly, we have to feed axis number 2 into the element number 1, like this, linear axis 1. Okay, linear axis 1 we have to feed value K2. So now we have set K1 and K2. There are two axes we have set. Okay, one second, let me connect to the charger. Okay, now here we need to mention the target position where we want to move our axis 1 and axis 2. So here using ed move, I have moved, for example, E1000 to the move interpolation absolute underscore one. This is the function block name that we are using. Dot position zero. Okay. Like in this, we have linear axis zero. So the position for this axis, this means axis number k1, we will have the element position zero. Okay, so similarly, like we have taken axis 1, axis 2 in the array element, similarly, we have to take the target position in this array element, array element. MCV move linear interpolate absolute 1, position 1 and position 0, we have taken 1000 and 2000. Okay, or you can also take the lesser value, whatever you want. Okay, similarly, you have to move some default values, axis group number, which group which group you want to interpolate, that you have to take. Okay, so we have just move linear interpolation underscore one axis group dot group number one. Okay, we have moved one into this because we want to rotate axis group number one. Okay, similarly in the direction selection you need to take one values. Okay, in the direction selection values, here you can see direction selection one. Okay, so just click, I'm just clicking shift F4 again. Okay, like this. So for interpolation, what I'm doing, I'm just clicking on group enable. I have already done. Yes. Now, if I click on this M3, okay, this M13, so you will see both the axis will operate, axis 1 and axis 2. Let me check. Okay, so you can check axis 1 is rotating and axis 2 is also rotating. Both are in synchronized motion. You can check here. Both, it is written there, synchronized motion means both are in interpolation. Okay, so it will go up to one axis will go up to 100 and up to then second axis will go up to 200. Okay, actually this is the acceleration time is very high, that's why it is taking little time. So you will check, it will go up to 100 until then it will reach up to 200.
Okay, so like this you can check, when I given the command of interpolation, it has reached to 100, and other axis has reached to 200. So this is how interpolation can be achieved. Okay, similarly if you want to achieve the synchronization, you can also do that in the similar way. Just we need to take the, first I'm removing the interpolation. Now I do not need the axis enable disable or axis group enable disable function. So for that we need to first mention the input axis and output axis. Okay, that you need to click here. For that, first you need to go into here, advanced synchronous control. Into the add-on data, you will get advanced synchronous control, and here you have input setting. So into the input setting, you need to right click and add new data. So you will open like this. So you have to mention your input axis. So I have mentioned axis 2 as my input axis, and similarly output setting you need to mention here, which will be your output setting, output axis. So I have mentioned here the axis 1 as the output axis. Okay, so axis 1 is my master axis, and axis 1 is my slave, or you can say follower axis, and axis 2 will be my master axis. Fine. So I have mentioned here like this. Now in the logic side I have to do is here like this. You have to, you have to take advanced sync function block. Into the function block, view, docking window, and element selection, you have this MCV advance. MCV advance. Here you have advanced sync. Okay, you need to take this function block. So in this function block, master axis, slave axis, you can directly connect, and you need to mention which is your master axis, which is your slave axis. Then this is the synchronization enable. Acceleration time, deceleration time, you can mention over here, and only you need to mention here like this. Move K2 to the name of the function block dot master dot axis number. So K2 is my master, so I have to move it into this. Similarly, MCV advanced sync slave dot axis number. So K1 is my slave, so I have to mention like this. Okay, now first of all I'm going to do the homing of both the axes, then I will show you the synchronization. Okay, both axes are home now, you can check both uh, axis 1 home. There is an error in the axis status in axis 2. Okay, if there is an error, you can just reset using the reset function block. Okay, like this you can reset, or you can also reset from here if you are on simulation or you are on PLC. But I suggest you to take a function block to reset the errors. Okay, now if I click on M5, it should reset the error. Okay, all access servo on. First of all, I have to make the access on, right? Like this, you can see both the windows together. Okay, jog axis, if I want to jog, yes, jog is working. Yes, jog is working. You can see the values are changing. Now homing is also working. M6. Yes, homing is working. Now in the synchronization, if I click on M15, you can check. Axis 1 is showing synchronized motion, but not axis 2 because axis 2 is master. Axis 1 is in synchronized with axis 2. So it is only showing synchronized motion. So if it is axis 1 is synchronized, if you rotate axis 2 only, then axis 1 will automatically rotate. Like if I rotate axis 2 and axis 1 I do not rotate, for example, axis 1 I am having a different button here because both the buttons are same. So if I take a button here which is different, so it will not rotate by jog command but by synchronization. Okay, okay, now I'm rotating axis 2. Okay, I'm rotating axis 2 into the forward direction. So you can check axis 2 is rotating, but axis 1 is also rotating. Okay, into the synchronized motion like this. So you can achieve synchronization using functional blocks like this. In axis 1, I have not given any command. You can check M201 is not, I have not given command into the jog operation, but it is in the synchronized motion. So like this, you can have synchronization also. So similarly, if you want to have some like some cam operation, so you just need to mention that cam here into the operation profile data. You can mention the cam profile. Here you can make any profile, any cam data, and you just need to mention the number profile data 1 to the output. Like here, you can mention the cam number. Then your in output axis will rotate as per the cam. Okay, like this, you can achieve cam operation also. So this was all about the function blocks library available for RD78G. If you have any query, any doubt, you can just mail me. I have dropped the mail ID into the chat box. You can just drop if you want to you are doing something and you want to know how to execute particular function block, then you can have. Okay, thank you everyone. Thank you for attending this webinar. I hope you have understood the concepts of different function blocks available in the function block library of RD78G4. Limit signal setting you can have here into the parameters. Into parameters, you have different settings. Upper limit signal, okay, and lower limit signal settings are here. Upper limit and lower limit. So signal where you have connected, which type of signal you have, like you have label, you have device, you have connected a constant, and from where it is coming, like bool type source. So here we have the settings, different settings you have. Gear ratio, Dinesan, you can have gear ratio from here in the output setting, in your here in output setting when you are synchronization. So here's the gear now. Main shaft gear, you can mention gear 1:1. I have taken only 1:1. That's why it was rotating at the same speed. If you want to change the speed, you can change the gear ratio from here. 1:1 or different gears are available here now. Okay. Any other? So thank you everyone. Thank you for attending the session. If you have more queries, you can just drop a mail to my mail ID. I have just mentioned in the chat box, sanjeev.k@asia.map.com. Thank you for attending the session.